Section 22 of the National Geographic Magazine, Volume 4. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avaí in September 2014. The North American Deserts by Herrn Professor Dr. Johannes Walter. Separate from Verhandlungen der Gesellschaft für Erdkunde zu Berlin, 1892, Heft 1. Translated by Robert Stein. 4 years ago I had the honor to report to you on the observations which I made with Professor Schweinfurth in the Egyptian deserts. Since that time I have been again in Egypt, have touched the desert of northern India, and have been much occupied with the literature of deserts, and last autumn I seized the opportunity offered by the 5th International Geologic Congress at Washington to look at the American deserts. The great geologic excursion through North America, under the professional guidance of our American colleagues, passed for some days through deserts and gave me opportunity for several side trips into neighboring deserts. Afterwards, in company with Dr. von den Borne, I spent 2 weeks in traveling through the deserts of Arizona, California, and Texas, and met with a hospitable reception in the tent camp of Professor Strerowitz of the Geological Survey of Texas. Through his kind leadership, I was enabled in a few days to visit the most interesting points in western Texas, in the Sierra de los Dolores and in the Sierra del Diablo. Our first acquaintance with a desert-like region was made in the Bad Lands of Dakota. When we awoke on the morning of September 5th, our train was on the prairie. A gently undulating plain allowed our eyes to roam to the distant horizon. The gray moraine soil was covered with a dense nap of grass, now sulphur yellow, now rust brown. Over it extended, gossamer-like, a silvery gray veil, formed of countless delicate ears of grass. Wherever a depression gave rise to an accumulation of water, there appeared a dark green swamp carpet, overgrown with reeds and rushes, and where the dry prairie grass had been lit by sparks, there were seen black bare spots with jagged fire-eaten edges, and studded with small blackened drift boulders. Inquisitive prairie dogs sat upright on their hills, a few butterflies were on the wing, one small bird soared in the clear air. On all the wide plain there was nothing else to strike the eye. In the afternoon there emerged on the horizon sharply outlined Table Mountains, and at Kurtz Station we found ourselves in a landscape full of Zeugenberge and mesas. The Americans call the Zeugenberge very appropriately "sentinel buttes," and for the blind pouch-like wadi valleys penetrating into the Table Mountains, the cowboys use the expression "rimrock." The rimrock valleys are of great value to the cowboys, because they can drive their great herds into them without danger of losing a single head, for the steep slopes from the gateway to the innermost recesses of these valleys prevent all possibility of escape. Quite similar sentinel landscapes were seen by us again in Utah, Colorado, and Arizona. At Ogden, a Mormon town at the northeastern end of Great Salt Lake, I left the train in company with Professor Krasnov of Kharkov. We traversed the tree-lined streets of the pleasant little town and ascended the slope of the Wasatch Mountains. Fields of helianthus covered the plain, low oak brush grew along the granite mountains, and scattered opuntias and artemisias proclaimed the dryness of the climate. Finally we reached a gravel terrace 100 paces broad, which could be traced as a horizontal band along all the mountain slopes, 120 meters above the bottom of the valley. This was accompanied by similar parallel lines which might be observed along the rocks to a height of 300 meters. A superb picture here offered itself to our gaze. At our feet, surrounded by fertile fields and orchards, lay the town of Ogden. An ingenious system of canals irrigated the land and caused a verdant oasis to rise in the midst of the salt steppe. Next we surveyed the bright blue mirror of the saline lake, from which jagged islands emerged in picturesque beauty. Toward the west there followed a white lustrous plain bounded on the far horizon by violet mountain silhouettes. At present the lake has an average depth of 4 meters, but there was a time when the wide valley basin, 4,500 square kilometers in extent, was covered by a lake 300 meters deep. At that period the breakers cut a terrace in the rocks of the lake shore, and while the lake water evaporated and its level gradually sank, there were formed the various shore lines which now may be traced as horizontal bands in parallel course along all the mountain slopes. Great Salt Lake is the last scanty remnant of old Lake Bonneville, and the salt desert is a dried lake bottom. In yellow radiance the sun's disk sank behind the mountain crags when on the Southern Pacific Railway we traversed part of the salt desert. The night fell quickly, and soon the desert gleamed in the moonshine like glistening hoarfrost. When we set out next morning from the lonely station of Terrace on a ramble over the desert, our expectations were raised to the highest pitch. Krasnov recalled his travels in Turkestan. I remembered the Arabian desert, and we looked around anxiously, scanning with care each pebble, each sandhill, each sagebrush, and each rock, in order to compare them with our experiences in Africa and Asia. While Krasnov quickly felt at home and everywhere discovered resemblances to the steppes of Inner Asia, I marveled to see a desert picture unwonted and strange to me. Wherever my eye might stray, it rested on the yellow bloom of Halophyta, the silver-gray bushes of Artemisia, and spiny cactuses. Among creeping opuntias I saw a few small moss cushions, and at the foot of the granite hills grew juniper trees 2 meters high, with stems a foot in thickness. We walked in short serpentine windings among bushes a foot in height. Some scattered spots were covered with brown pebbles, small sandy watercourses wound, with many a loop, to end on the dazzling white salt plain. As we approached that plain the scrub became scantier, rising island-like from the flat surface, and finally there lay before us the floor-like horizontal plain of saline clay, entirely devoid of plants. The salt formed a coat of fine powder over the grey clay, and the small crystals glistened and sparkled in the sun like fresh fallen snow. The ground was honeycombed with polygonal heat cracks, and reflected a glare so intense and dazzling that one could look about only with half-shut eyes. Krasnov told me that this landscape agreed in many points with the deserts and tachirs of Inner Asia, but I found myself face to face with an entirely new type of desert. I was wont, after several hours' ride over gravel-covered Sarir or brown Hamada, to come to a wadi distinguishable, even from afar, from its plantless surroundings as a green band. I had often been engaged with my Bedouin for an hour in gathering dry scrub in order to have the fuel necessary for the fire. Here, in the American desert, there were plants in abundance, and only the increasing salinity of the soil checked vegetation. Apart from the salt-covered lowlands, I received everywhere the impression of an Egyptian wadi vegetation. Bush stood beside bush, and between them was plantless soil, but on looking over the region from an elevated point, everything seemed sprinkled with blooming green bushes. Now this phytogeographic habit, or, if I may so term it, the wadi character of the whole desert, is not confined to Salt Lake Desert, but a similar abundance of plants was found by me in the Mojave Desert, the Gila Desert, and the deserts of western Texas. It may often have called forth a smile on the part of my companions to hear me complain again and again of the many plants in the North American deserts, but I cannot sufficiently emphasize the difference as compared with northern Africa. The salt-covered tracts on the shore of Great Salt Lake, the bottom of the ancient Lake Bonneville, are indeed absolutely plantless, and in this respect delight the heart of the desert traveler. But it must be remembered that in this case it is merely the increasing salinity of the soil that kills vegetation. And when we recall that we here tread on the bottom of a drainless, desiccated diluvial lake, the theory of a Saharan sea, which in the case of northern Africa may well be assumed to have been definitely refuted, might seem to find complete confirmation in Great Salt Lake of Utah. There we have a desert whose poverty in vegetation is an effect of evaporated salt water. I supposed at first that this great wealth of plants in the desert of Utah and Colorado is a consequence of the great topographic altitude, for these deserts have an altitude of more than 1,500 meters. The plateau of the southern Galala in the Arabian desert, in fact, is also much richer in plants than the lowlands of the Wadi Araba. But in the low-lying deserts of Southern California, I soon convinced myself that this conjecture was incorrect. The depression of the Coahuila Desert, 260 feet below tide, was unfortunately traversed by me at night, from Indio to Tortuga. But the picture of the landscape which presented itself early next morning at Aztec was almost as rich in vegetation as the Van Horn Desert in western Texas, although Aztec lies at an altitude of 500 feet, Van Horn at 4,500 feet. It is apparent from this that topographic altitude is not the cause of the wealth of vegetation in American deserts. It seems, on the contrary, either that the average precipitation in American deserts is greater, or that American desert plants are better adapted to dry air. According to Mr. Marcus E. Jones of Salt Lake City, that place has an annual rainfall of about 15 to 16 inches, Salt Lake Desert about 6 to 10 inches. The conductor of the Southern Pacific Railway, who has traveled through Gila Desert daily for many years, told me that there is a rainy season in that desert in July and August. The desert sky, at other times so clear, is then clouded, there are occasional thunderstorms in the afternoon, and irregular rain showers fall, their area being so limited that at times the strip receiving rain is only 5 kilometers broad, though the water there covers the ground to a depth of a foot. For the deserts of Texas, according to von Streerovitz, a mean annual amount of rain cannot be given at all, for in some cases it does not rain for 2 years, and again there is a rainfall of 2 inches in 2 hours. The plants of the American deserts attain no inconsiderable dimensions. In southern Arizona we rode for 3 hours through a desert in which columnar cactuses half a meter in diameter and 7 meters in height were to be seen by the thousand. Never have I witnessed so curious a sight as these huge specimens of Cereus giganteus in such multitudes. The salsolaceas and artemisias form bushes a meter in height, and their branches are of an arm's thickness, and, while in the Arabian desert one finds but slight protection against the sun's rays under acacias and tamarisks, in Utah the upper slopes bear shade-giving juniper trees. While there exist thus in the conditions of vegetation wide differences, on the other hand there are a series of important and characteristic desert phenomena in North America and Africa that present surprising resemblances. In the beginning of October I rode from the Needles through the Mojave Desert. On both sides of the railway extended an almost horizontal plain, gently rising toward the granitic and volcanic mountains. So far as the eye could reach, I saw everything covered with scattered desert shrubbery, sprinkling even the slopes of distant mountains in the form of small green points. All mountains, mostly volcanic rocks, dikes, and ash cones, rose island-like from level desert land. The horizontal plain and the steep mountain slopes were not linked together by a debris-covered foothill, but plain and mountain slope intersected without any transition. It is surprising to see steep mountainous islands rise from a sea of debris, and yet this phenomenon is characteristic of all deserts that I have seen in Africa, India, and North America. Just as the granite mountains of Sinai or of the Gharib rise island-like from the debris plain in imposing dimensions, and as the plains rise toward the base of the mountains so slowly as hardly to be perceptible until the craggy granite colossus rears its head like our own mountains of massive dolomite, so in the Sierra del Diablo do the plateaus of the Carboniferous limestone rise steeply from a boundless plain, of whose accumulated debris masses one may form an idea on learning that near Torbert at the foot of the Sierra Van Horn a well was dug 1,050 feet deep in debris. The phenomenon becomes especially striking because it is noticed that there are no debris deltas at the mouths of valleys 1,000 feet deep. There, too, the horizontal plane is seen to abut directly against the steep slopes of the mountains. If we conceive each landscape picture as the result of definite processes of denudation, the relation of such a desert plain to its rocky cliffs will at once indicate that denudation in the deserts acts differently from what it does in Europe. But this horizontality of the surfaces of denudation has a further claim on our interest from another point of view. In the geologic exposures that exhibit to us sections through parts of the earth's crust, it is found very frequently that the rock is parted by horizontal planes into layers lying above each other. This structure is called stratification. Now, that which in the cross-section of a block of strata appears as a horizontal plane is merely the expression of the fact that at a certain time in the formation of that body of strata, the freshly formed sedimentary surface had the character of a widely extended and approximately horizontal plane. If we now look around on the earth's present surface for regions in which the freshly formed deposits with horizontal planes are being formed, we find them, in the first place, at the bottoms of seas and large inland lakes. In them are formed deposits with horizontal surfaces, that is to say, stratified deposits. Now, it is very important to note that besides the sea bottom, there exists another class of regions of the earth's surface on which the products of denudation are spread with great regularity over wide horizontal areas. These are the deserts and steppes. Both, therefore, are areas which must not be left out of view in the discussion of the origin of stratified deposits. Stratification does not all originate under water. The activity of denudation is a double one. It destroys the rocks of the earth's surface and transports the comminuted material from its place of origin. In our regions it is water that destroys the rocks, it dissolves them chemically, and frost fissuring comminutes them mechanically. Water is also in our latitudes the most important transporting agency. In the desert it rains but seldom. The time in which water may there destroy rocks and transports debris is at most 65 days in the year. It has been thought that during the remaining 300 days, denudation in the desert is at a standstill. Yet careful, unbiased study teaches that in this 300 dry days, denudation is intense. A burning sun beats down on the rock surface, unprotected by any plant cover. In Texas, daily variations in temperature of 40 degrees centigrade are not at all rare, and large and small stones are cracked by the heat. Often have I picked up the halves of such cracked pebbles still fitting together. In Texas I saw granite blocks as high as houses divided by wide cracks, and Mr. von Streerovitz told me that he had seen and heard the cracking of such blocks. The variously colored constituents of the granite become heated to different degrees and fall apart in the form of coarse gravel. In a valley of the Sierra de los Dolores, a rainfall had filled the rocky bottom of the valley with granite gravel to a depth of 3 feet. This gravel had been formed by insolation on the granite rocks in the course of years. Deep caves weather out of the granite wherever the water remains longer, and these increase the mass of the products of denudation. Thus, rocks are destroyed by dry heat at a time when denudation by water sinks to a minimum. On the 300 dry days of the year, the process of rock destruction continues uninterruptedly. On rainy days, of course, the loosened rock material is carried off by running water. That such a desert rainstorm, falling like a cloudburst, may carry off immense masses of debris, needs no proof. The question is merely this: is the transportation of the products of denudation at a standstill in the desert during the 300 dry days? To this question also we must reply in the negative. Almost daily I saw columns of dust traveling slowly over the plain. These raise great quantities of loose material high in the air. There this material is caught by horizontal air currents and carried farther away. I also saw in Colorado how within 1/4 of an hour the desert plain was wrapped in clouds of dust so dense that one could hardly see 2 kilometers away, while previously the eye might discern everything within a radius of many miles. Thus we see that even when it does not rain, there exists in the desert a transporting force, and that on the 300 dry days neither the destruction of rock nor the transportation of the products of destruction is at rest. We also recognize that this dry denudation, as it has been called by an English reviewer, is of intense power, and may well be compared qualitatively, though not quantitatively, with the denuding effect of water. It will be exceedingly difficult, however, to find a scale by which erosion, that is, denudation by water, can be compared with deflation, that is, denudation by wind, and so long as such a scale is wanting, all conclusions regarding their relative activity must rest on subjective estimates. Many rocks and rocky surfaces of the African deserts are covered with a peculiar coating, which may be designated as brown protective coat or desert varnish. This coating is also found widely distributed in the deserts of North America, and if I did not succeed in forming a definitive judgment concerning the origin of this product in Egypt, I have now in America made observations which promise to bring the problem nearer to its solution. Mr. von Streeruwitz, in the beginning of September, had made excursions to several parts of the Sierra del Diablo, observing instances of the protective coat, which he intended afterward to show me. Toward the end of September cloudbursts descended there, and when in the beginning of October we entered the valleys of the Sierra, we found to our astonishment that the protective coat had everywhere been torn away, and only a few shreds of it hung against some of the walls. Even where there had merely been a pool of water in a depression, and where therefore the chemical rather than the mechanical force of the water had been active, we found the desert varnish removed. From this appears with certainty what previously I could express only as conjecture. 1. That the brown protective coat is not formed by the aid of water, and 2. That it is torn off and removed wherever rainwater has access. Now, the latter fact also throws some light on a phenomenon which was previously a perfect enigma. In the African deserts, sandstones or limestones, more rarely granite, are found weathered in such manner that the face of a rock wall is broken by niches or crannies 10 to 100 centimeters high, 5 to 50 centimeters broad, separated by columns reaching a meter in height. Behind these columns, that is to say in the interior of the rock wall, runs a passageway, at times large enough to allow a man to crawl through it. Both Professor Schweinfurth and myself were convinced that in the formation of these columned passages rainwater had played a part. Our views diverged only on the question whether the columns had at one time been washed by descending rain rills, or whether that had been the case with the holes between them. By the recent observations it is placed beyond doubt that only the holes can have been formed by water. Professor Sickenberger of Cairo has been engaged for a year on investigations on the chemical processes involved in the formation of desert varnish, and important results are to be expected from him confirming the views here set forth. I attach great importance to a letter I received from Professor von Streerovitz, who, in his laboratory at Austin, kept a protective coat absolutely free from manganese in an ozonized atmosphere for 2 weeks. It rapidly grew darker, and in the course of a few months assumed the color which those rocks had before the cloudburst. This fact shows how correct is G. Rolfs in calling attention, as he did again recently, to the significance of electricity in deserts, and how important would be the institution of exact determinations of electricity in some desert. From what has thus far been stated, it is evident that the North American deserts agree with the Egyptian deserts in all essential and characteristic points. There are striking differences in plant geography, it is true, in that the American deserts on the whole are much richer in vegetation, probably by reason of greater precipitation. It is probably for this region that erosion plays a larger and more important part than in Egypt. But the topographic character is the same. The prevalence of horizontal plains with island-like mountains rising from them, the frequency of isolated Zeugenberge, or island mountains, and of amphitheaters in the valleys, the intense energy of insolation, cracking boulders and pebbles and causing vari-colored granite to crumble into loose gravel, the appearance of mushroom rocks and columned galleries, and the wide distribution of the desert varnish, a phenomenon which must be regarded as a specific effect of dry climate and scarcity of rain. The denuding effect of wind is apparent not only in the characters of the surface forms just named, which are essentially different from the forms of erosion, but it may also be observed directly when dust storms career over the desert. As in northern Africa, so in North America, there are found 4 types of denudation products or sediments: gravel deposits, sand dunes, clay tracts, and salt deposits. In view of such agreement in the primary and secondary geologic phenomena of the deserts, geographically so far apart, of northern Africa and North America, despite the different conditions of vegetation, one is justified in regarding the phenomenon of desert formation as one of the great telluric processes, a process having its own laws, just as much as the glacial phenomena of the polar zone or the cumulative weathering of the tropics. Transferring this principle to the domain of earth history, there arises the problem of searching for the remains of fossil deserts in the strata of the earth's crust with the same care with which in recent time fossil glacial periods are reconstructed. But the study of deserts has another important consequence. The desert is an extreme of climatologic conditions. Dry air and dry heat, which in our temperate climate make their appearance on a few days only in the year, are active in the desert for the larger part of the year. Their effect in the desert is prominent. In our regions it occupies a very modest place, but it would be unfair to deny their denuding agency even in our regions. There are so many phenomena near us which can hardly be explained as effects of water and ice, but which become easily intelligible as soon as we recognize dry air in motion as a geologic force. There is perhaps not a spot on earth that bears no trace of erosion, neither, on the other hand, is there a spot where the activity of wind denudation or deflation is entirely absent. It is only a question of unbiased observation of nature, and of not attributing to water things which it cannot accomplish. How close together and in how intimate union erosion and deflation act is shown by an eloquent example, the famous Colorado Canyon in Arizona. Most of the members of the great excursion expected that our way from the railway at Flagstaff to the Colorado Canyon would lead through a desert. What was our surprise, therefore, when we found that it led for 120 kilometers over a plateau more than 2,000 meters high, with prairies and beautiful pine woods. The shady growth of Pinus ponderosa extended to the very edge of the canyon gorge, and as we climbed the last steep slope we were able to come within 2 steps of the canyon without imagining how close we were to the coveted goal. 1 step, and we stood on the verge of a gorge 2,000 meters deep, and only at a distance of 20 kilometers did we see the steep verge of the other shore. A magic twilight as yet reigned in the purple depth; only the topmost crags of some rocky towers burned with the rosy glow of the rising sun. Our eyes swept along the horizon, and as far as they could reach there appeared an uninterrupted mantle of forest; only toward the southeast the snow-covered peak of Mount St. Francisco emerged like another Etna, while toward the north, more than 200 kilometers away in an air line, arose the gourd-like Mount Navajo. Again we looked down into the fathomless depth, gradually illumined by reflection from the upper peaks glittering in the sunlight. The rock walls seemed to glow as with transparent light, and only with difficulty could the eye distinguish details. Little by little the purple glow and the deep blue shadows of the abyss disappeared, and as the sun rose higher and higher the shadows grew shorter. Like jutting battlements and fairy-like palaces, one rock structure after another disclosed itself. At last we were able to scan the steep walls, to recognize with complete distinctness the Cambrian unconformity, and even at one point to see the river rushing along. The relation of the bed of the Colorado to the canyon can be better recognized, however, if, proceeding along the upper edge eastward, one finally reaches the point seen and described for the first time by the Spanish commander Coronado in 1542. Spanish Point lies at the extremity of one of those wooded tongues of land which project so far toward the middle of the gorge that one is able to survey the river for a considerable distance along its middle line. It has already been pointed out by Dutton, and the view from Spanish Point easily shows it, that the canyon is divided into 2 parts. At the bottom the river is seen rushing along in a narrow gorge cut in gneiss, and our ears catch the muffled roar of the mighty stream that rolls its brown-red flood over rapids and reefs. The bed at times is so narrow that the rocks rise perpendicularly 400 meters from the water, and only on turning northward, where the little Colorado breaks forth from its narrow gateway of rock, do we see the river bed widening and even bordered by a green fringe of low bushes. That this trench traversed by the Colorado and mostly of gorge-like narrowness is an effect of erosion, that it was cut by the river and is still being deepened, is not open to the least doubt; but when we turn our eyes to the edge of this interior groove of erosion we see at once a different landscape. The strata referred to the Silurian and Devonian represent a shelf several kilometers in breadth, designated by Dutton as the esplanade. The edges of the strata appear distinctly as delicate isohypsal lines, and the valley widens with very gentle slope, to be succeeded again by escarpments 1,000 meters high. But the widening above the esplanade is not uniform, for the promontory of Spanish Point forms a sheer wall only a few kilometers distant from the river, while alongside it deep semicircular kettles enter 5 to 8 kilometers into the plateau, and thereby carry back the edge of the canyon gorge as far as 10 kilometers from the erosion groove of the river. Were we to cast a bird's eye view on the whole valley system, we should see in the middle a uniform, steeply carved groove, which at a certain point of its depth all at once widens greatly and appears fringed with deep semicircular bays. If from Spanish Point we look westward, we gaze into such an amphitheater. With sheer walls 800 meters high it rises from the esplanade; nowhere could the bold foot of a mountain climber find a hold; with dull rumbling, the blocks loosened by our feet from the edge of the abyss tumble down into the vast depth. The upper edge is cut sharp as with a knife. Nowhere do we see a rivulet descending. Nay, the plane of the plateau slopes so steeply away from the edge that even in heavy rainfall no torrent could tumble over it. The whole region is strained toward the land, away from the gorge. Like an enigma these amphitheaters now appear to us, all the more so when we learn from Major Powell, the famous explorer of the canyon, how rarely it rains here. Major Powell had not thought it necessary to take along tents for us, and when in one bad stormy night we lay shivering around the smoky fire, unprotected against the hail and the streaming rain, not a few of us must have received the impression that we were in a region of large precipitation, and yet that storm was an unforeseen exception. But even if rain were more frequent than it is, still on account of the topographic conditions of drainage, the amphitheaters would be affected only by the erosion of that water which falls on their surface. Bursts of rain from the thunderstorms generated within the canyon, such as were graphically described to us by Major Powell, may indeed wash down all the debris which has become loosened in the course of the rainless period, but nevertheless the denuding effect of water can there be only secondary. But where is the force that carved such amphitheaters? Where is the cause of so singular forms of denudation? Again we stand face to face with the question whether in these kettles denudation is at rest during the 300 rainless days. If we observe with unbiased minds what are the forces that act during these 300 rainless days, we see dry air and dry heat exerting their destructive influence on the rocks. The eye trained for such processes recognizes that the heat of the day, alternating with the cold of the night, may produce the same effect as Fischer frost in our latitudes. We ourselves experienced variations of temperature of 30 degrees Celsius within the canyon. Thus insolation and weathering penetrate into the rocks and break them, and the wind carries off the light powder of the weathering. The harder ledges of rock are undermined without the aid of eroding water, hang over and await the first rainstorm. Now comes one of those rare cloudbursts. The water everywhere finds loose debris and shaky blocks. Thus, the relatively small amount of water is able to detach and sweep down a much larger amount of debris, which afterward the Colorado carries out into the Gulf of California. Thus we see in the canyon of the Colorado an interesting example of the combined action of erosion and deflation. We recognize in the inner gorge a simple channel of erosion. We observe that the upper amphitheaters owe their existence to the cooperation of erosion and deflation. Now, what we here see in the Colorado, that we see everywhere on earth where the soil is not covered by a mantle of water, snow, or vegetation. There is no need of traveling into the deserts in order to recognize the denuding activity of wind, and in the driest desert the traces of erosion may be observed. There is no region absolutely devoid of precipitation, and, on the other hand, deflation may be observed in the rainiest climate. When on a dry autumn day you walk along the highway and are annoyed by whirling clouds of dust, you are witnessing the denuding effect of wind. Every sand dune is the result of the same force. Every clay bed, Lehmlager, teaches how vast deposits are produced by wind, and the loess beds of China are supposed to be merely a product of deflation. We say of the wind that it sweeps over the ground, for this word means nothing else than that the wind cleans the ground of all loose particles that cover it. Translated into technical geologic language, it is called deflation, but that means nothing else than the everyday word sweep. One must learn to recognize the sweeping activity of the wind not only in the desert, but everywhere, and in so doing, to detect in its very beginning the process whose final product von Richthofen sees in the loess. End of section 22.